Assalamualaikum and hi everyone, welcome to our group presentation. In this video, we will learn about mathematical terminology and construction method. First of all, let me introduce to you guys my group members. The first one is Ahmad Zudi bin Azman. The second one is me, Nur Batrisha binti Amaluddin. The third one is Amira Farhana binti Muhammad Adnan. And the last one is Nurul Aina Biha binti Mustafa.
So, firstly, I'm gonna tell you about a mathematical terminology in content. So, in dealing with proof, there are 4 terms that you will come across. A mathematical proof, which is a list of statements in which every statement is one of the following, which is, firstly, an axiom, second, derived from previous statement by rule of inference, and thirdly, is a previously derived theorem. So let's go back and have a flashback on what is an axiom in math. That is a fundamental logical statement that you assume to be true in order to build a theory. For example, axiom can be 2 plus 2 is 4 and 3 times 3 is 9, etc. In geometry, we have a similar statement that had a line can extend to infinity. This is an axiom because you don't need a proof to state its truth as it is evident to itself. So, let's move further. My friend Batrisha will explain about hierarchy of terminology. So, let's go.
Next, we move on to hierarchy of terminology. There are few terms that we need to know in proving a statement, which are preposition, theorem, lemma, and corollary. The first one is preposition. Preposition is a true statement that you are trying to prove. The second word is theorem. Theorem is a proposition that is extremely important or difficult to prove through mathematical statement. The third word is lemma. Lemma is a true statement used in proving other true statement, that is, less important theorem that is helpful in the proof of other results. The last one is corollary. Corollary is a proposition that follows as a result of knowing that a theorem is true.
There are a lot of methods to be used to prove that this statement is true. One of them is construction method. Construction method is used when the statement in the backward process have the quantifiers such as there is, there are, and there exists. These quantifiers is called existential quantifiers. For example, if the proposition given is if such and such, there is an object with a certain property such that something happens. Our A statement would be such and such, and our B statement is there is an object with a certain property such that something happens. Here, we can see that the B statement has the existential quantifiers, which is there is. So we need to use the construction method to prove this statement, while the information in statement A can be used to accomplish the task. There's a guideline that we can follow on construction method. First, write the statement for A and B from the proposition given. Second, identify the existential quantifiers in the statement B and ask key question for the statement B. This is to get the answer to write at the statement B1. Thirdly, identify the object to be constructed from the backward statement and become forward statement A1. Next, use the hypothesis together with your creative ability to construct the desired object. Lastly, establish the constructed object that satisfies the certain property and the something happens. This is why it is important to identify the object, certain property, and something happens at the proposition statement.
Now we understand the definition of construction method. So let's move on to the example. Example 1, the question is if the function fx equals to 3x plus 2 is continuous on the interval 1, 5, then there exists a value c that satisfies the mean value theorem MVT for integral. So first we have to analyze the hypothesis and conclusion, as well as there is an existential quantifier in the conclusion. As we learned before, the proposition for this method is if such and such, there is an object with certain property such that something happens. By using this proposition, we can analyze the hypothesis A, which is fx equals to 3x plus 2 is continuous on 1, 5. And the conclusion B is there exists a value C that satisfies the theorem. So we look at the B first, the backward process. So how can we show that C can satisfy the theorem? Of course, we have to show that C is in between the interval given. So B1 will be there exists C between 1 and 5. Then from B1 here, are there any questions that we can ask? No, right? So the desired object from this backward process is C. Therefore, we continue to the forward process. First, we have to write the formula for mean value theorem MVT for integral from our previous knowledge. So A1 will be integrate a to b fx dx equals to fc in bracket b minus a. And then we apply the formula by substituting the information given in the hypothesis. So A2 will be integral from A2 from 1 to 5 3x plus 2 dx equals to fc in bracket 5 minus 1. And then lastly A3, we have to integrate and solve the function, and we get c equals to 3, and we know that 3 is in between 1 and 5, so we can show that A3 is logically equivalent to B2. So the condensed proof for this example is to prove that fx equals to 3x plus 2 is continuous. We need to find a value c between the interval 1, 5 by mean value theorem for integral, which is integral a to b fx dx equals to fc in bracket b minus a. Then obtain integral 1 to 5 3x plus 2 dx equals to fc in bracket 5 minus 1. Solving the integration, the value of c is equals to 3 is derived, and this value is between 1 and 5. After we finish write our condensed proof, we have to put a small box at the end of the proof. This indicates that the proof is completed. Now let's move on to the example 2. The question is prove that there is an integer x such that x squared plus x over 2 minus 1 over 2 equals to 0. Is the constructed object unique? First, we have to analyze the hypothesis and conclusion. So the hypothesis will be x squared plus x over 2 minus 1 over 2 equals to 0. And the conclusion will be there exists an integer x. So first, we have to look at the conclusion. Are there any key questions that we can ask? No. Therefore, the object will be x. And then we continue to the forward process. We look at the hypothesis first. We have to multiply the equation with 2. So A1 will be 2x squared plus x minus 1 equals to 0. And then we factorize the equation. So A2, x equals to 1 over 2 or x equals to negative 1. And then we look at the conclusion before. There exists an integer x. So x is an integer. X equals to 1 over 2 is not an integer, but negative 1 is an integer. So last A3, x equals to negative 1, which is the only integer solution for the quadratic equation. So A3 is logically equivalent to B. Last but not least, the condensed proof for this example is given a quadratic equation x squared plus x over 2 minus 1 over 2 equals to 0. By factoring equation, use the values x equals to 1 over 2 or x equals to negative 1, where x equals to negative 1 is the only integer solution for the quadratic equation. Thus, the constructed x is unique. And don't forget to put the small box at the end of the proof.
Our last example, if x is even, then x squared is even. First, we need to identify the statement A and B. Statement A is x is even and statement B is x squared is even. Here we can see that there is no existential quantifiers at the B statement. If we want to use construction method, there must be quantifiers there is at the B1 statement. So what we can do is add the quantifiers there is at B1 statement, which will be there is an integer k such that x x squared equals to 2k. Next is forward statement, which is x equals to 2r for some integer r. Step A2 is therefore x squared equals to in bracket 2r squared equals to 4r squared equals to 2 in bracket 2r squared equals to 2k, where k equals to 2r squared. With this statement, the statement in A2 is equivalent to B1, which is the statement is proven to be true.
Okay guys, so the conclusion is mathematical terminology help us to analyze a statement in proving method. And next is contradiction method is useful technique when the last statement in the backward process contains no or not. Okay guys, I think that's all from us. Thank you for paying attention to our presentation. That is all from us. Thank you.